It says, the point given below is on the terminal side of an angle theta. Find the exact value of each of the 6 trig functions of theta, and the point is -7, 2. So on a graph, what that looks like is you go -7 to the left, so -7, and then 2 up, and then you're going to draw and close in your triangle back to the center. So that's what the triangle looks like. In order to find all the 6 trig functions, though, you are going to need all 3 sides of the triangle, so we need to solve for that last side, the hypotenuse, using -7 squared plus 2 squared equals c squared. So you have 49 plus 4 is equal to c squared. It's 53 equals c squared, and then we'll just take the square root of both sides. So we have c is equal to the square root of 53. And normally we would put plus or minus when we take the square root, but since we know that a distance has to be an actual positive number because it's a distance from this point up in the top left to the bottom right, we know that it has to just be positive. So even though we get positive and negative, we just assume for this case it's positive. Then we're ready to list the 6 trig functions. So we have sine, cosine, tangent, secant, secant, which is the opposite of cosine, and then cosecant, which is the opposite of sine, and cotangent, which is the opposite of tangent. And another thing you need to know here is they're talking about from this middle angle right here. That angle with the center, with the origin, is always the angle that you have to look from. So while you're looking from there, that's how you're going to define the rest of these. So for sine, we have opposite over hypotenuse, that's 2 over the square root of 53, which we are going to simplify. Cosine, which is -7 over square root of 53. Remember, that's adjacent over hypotenuse. Tangent, opposite over adjacent. Cosecant, which is the opposite of sine. Secant, which is the opposite of cosine. And cotangent, which is the opposite of tangent. Now we're almost done, but we do have to clean up a couple of these. For example, you can't have a square root in the denominator, so you're going to multiply that by square root 53 over square root 53 to get 2 radical 53 over 53. And that'll be your final answer for sine. Same thing with cosine. We don't need to walk through that, though. Something to note is if you ever have a negative in the denominator, like here for 2 over -7, you should really rewrite that as tangent of theta is equal to just -2/7. Bring the negative out front, because if it's positive divided by negative, the whole answer is going to be negative. So in the last section, we talked about angles that go around the circle more than once. And you're probably wondering, like, what's the difference? If it goes around the circle more than once, isn't that the same angle? And it's true, which is, in this section, we introduced this word reference angle. And what a reference angle is the angle that makes it back to the x-axis. The first step is just drawing the angle that it gives you, like 875 degrees. We need to figure out what that is. So we know that this is 360 degrees, and then we'll go around again, and that's 720 degrees. And then how much do we have left? I mean, this is just deciding 875 minus 720. Okay, so we have to go another 155 degrees to make this work. So we'll go 155 degrees more. And we're going to be somewhere over here because we know this would be another 180 degrees. So, this angle's somewhere over here at 155. And the reference angle is just asking, what is this angle that makes it back to the closest x-axis? What's the angle that makes it back to the closest x-axis? So if we have to go 155 degrees, let's see, this would be 90 degrees. It would go 90 from there to there. Then we'll do 155 minus 90. We have 65 degrees left. So this is another 65 degrees. And then so we know from here to here, if that's already 65, from here to here is just going to be 25 degrees. This gets a little bit harder when you're doing things in radians, like we have here, 19 pi over 9, but you need to understand that 180 degrees is the same as pi radians, like we learned in the last lesson. And 360 degrees is the same as 2 pi radians. Think about 19 pi over 9 for a second. If it was 18 pi over 9, that would just be 2 pi. So this one's really close. It's 19 pi over 9, which means it goes 9 pi over 9, or just pi, 18 pi over 9, or 2 pi, and then it goes an extra pi over 9, an extra 2 pi over 9, even though it's already gone 18 pi over 9 to complete the full circle. And that's where the angle will stop. So we're going to draw on our angle, and then ask ourselves, what is the angle required to get back to the closest x-axis? So in that case, this is the closest x-axis. And this problem kind of solved itself for us because since it went just a little bit extra, to get back to that x-axis, we just need to go pi over 9. One last thing that you need to know about reference angles is that they are never negative. So even if the angle they gave you originally was a negative angle, like let's say instead of going in the positive direction like we did in our two examples, you had to go in the negative direction to get to your angle. So let's say, they gave you some negative angle to start with, they want you to find the reference angle, so you went all the way around, and then let's say you stopped here, but the reference angle back to the x-axis is going to be here. So even though they started you with a negative angle, your answer for reference angle will be positive. Reference angles are never negative.